Determine values, if any, of such that the given system is inconsistent. For the system negative x1 plus 2x2 minus x3 equals 1, 2x1 plus 8x2 plus x3 equals negative 2, x1 minus 2x2 plus ax3 equals 1. Our first step is to convert to echelon form by switching row 3 and row 1. This results with x1 minus 2x2 plus ax3 equals 1 being on top, and negative x1 plus 2x2 minus x3 equals 1 being on the bottom. Next, we're going to multiply the new row 1 by negative 2 and combine that with row 2 to eliminate the x1 term. This will lead us to get 2x1 plus 8x2 plus x3 plus negative 2 times the quantity x1 minus 2x2 plus ax3 equals to negative 2 plus 1 times negative 2. This will then simplify down further to get 2x1 minus 2x1, 0x1, 8x2 plus 4x2 equals to 12x2, x3 plus ax3 will equal to, x3 minus 2ax3 will equal to x3 minus 2ax3, and the negative 2 plus 1 times negative 2 will equate to negative 4. Simplify this further to receive 12x2 plus 1 minus 2a times x3 equals to negative 4. Using this formula, this new echelon form, new matrix form, we combine row 1 and row 3 to cancel out the x1 and x2 terms. So, this results with us receiving a minus 1 times x3 equals 2. Now that we have our form in echelon form where the leading variables are x1, x2, and x3, we can solve for x1, x2, and x3. Our first step to solve for x1, x3, is to set and simplify this equation. Multiplying dividing a minus 1 across the equation sign, the equal sign, 2 will give us 2 over a minus 1. This is our new x3 value. Solving for x2, we will take the x3 value and plug it into the second line equation and simplify. 1 minus 2a times the quantity 2 over a minus 1 will simplify to 2 minus 4a over a minus 1. This will then combine and be moved over to the right side of the equal sign to give us 12x2 minus 4 minus 2 minus 4a over a minus 1. Multiply the negative 4 by a minus 1 over a minus 1 to receive negative 4a plus 4 minus 2 minus 4a, minus and minus is plus. Combine the terms and you receive 2 over a minus 1 is equal to 12x2. Divide everything over here by 12 and you receive 2 over 12a minus 12, which simplifies to 1 over 6a minus 6. Using the x3 and x2 term, we can solve for x1 in the first line. Plugging x2 and x3 into the equation and distributing, we receive x1 minus 2 over 6a minus 6 plus 2a over a minus 1 equals 1. From here, we move the a terms over to the right side of the equal sign, and we simplify the 2 over 6a minus 6 into a 1 over 3a minus 3. This gives us a common denominator to solve the rest of the problem with. We multiply 2a over a minus 1 by 3 over 3 to receive negative 6a over 3a minus 3. We multiply 1 by 3a over 3 over 3a minus 3 over 3a minus 3 to receive a 3a minus 3 over 3a minus 3. From here, we combine all like terms and simplify down to receive negative 3a minus 2 over 3a minus 3. Using the x3, x2, and x1 terms, we can now look at what makes the system inconsistent. The common theme between all these terms is an a term being in the denominator that can affect the availability and possibility of our final answers. Say the denominator of any of our results is 0. This would lead us to have an inconsistent function, an inconsistent system, because anything divided by 0 does not exist. And if we were to plug in the value of 1 for a, for all of these values, we would receive a value divided by 0, which does not exist. Because 1 minus 1 is 0, gives us 2 over 0. 6 times 1 minus 6 gives us 1 over 6 minus 6, which gives us 1 over 0. And 3 minus 2 over 3 minus 3 is going to give us negative 5 over 0, which also does not exist. Therefore, plugging in 1 for any of the a values will give us denominators equal to 0, and therefore the system will be inconsistent when a is equal to 1.